So let me pick a couple of these to do for you, just to make sure you're not running in circles. Like this one here, cotangent of 18 degrees. We have the angle. Well, first thing we should identify, cotangent. Does it appear on your calculator? Is it a key on your calculator? No, it is not. So that means we're going to have to use that reciprocal key, the x-1 key at some point. So now we need to know, first of all, cotangent goes with what function? Tangent. So we're going to use the tangent key on your calculator. So I'm just writing this down for right now. So the question is, do we need to use the second button? How we determine that is, do we know the angle?
Yes.
Yes. So we know the angle, which means we do not need to use the second key. So it's just the tangent key. And we're going to put in the 18. We're going to close the parentheses. Since we did not use the second key, we close the parentheses first,
Right.
and that reciprocal key, or the x-1, goes outside the parentheses. And we hit equals. And so it'll be tangent, 18, close, reciprocal, 3.078, or 3.0777. That is the cotangent of 18 degrees. Let's drop down to the one on the bottom here. It's cotangent. Does that button appear on your calculator? No. So what function are we going to use? Tangent again. Do we know the angle? No, we are looking for the angle, which means we have to use the second key. So that means it's not really going to be tangent, it's going to be an inverse tangent that we're using.
Which would be arc.
Which is the arc tangent, yes.
So then it's the second
tangent. And now since we used the second key, the reciprocal goes inside the parentheses. The x-1 goes inside the parentheses. So second tangent, 0.396, x-1 close. 68.40 degrees. Yes, sir.
So it'd be fair to say that dealing with these secants and cosecant tangents,
Yes.
tangents, we have an inverse function that x-1 is inside the parentheses.
Exactly. If you have to use the second key to use an inverse function, the x-1 is inside. If you're just using the key to use a regular function, the x-1 is on the outside.
And no matter what, when we do with these three different ones,
Yes.
we have to have the x-1.
If the key, if it does not appear as a key on your calculator, which would be secant, cosecant, and cotangent, you have to use that reciprocal, the x-1.
Okay.
Now, like I said, this is still recording. I have no problem putting this on the recording. After we quiz on this, I have no problem if you forget these three functions exist.
That's been it.
Yeah. If you ever, in industry, run into something where you need one of these three functions, you have my permission to call me at home, and I'll talk you through it.
That's your phone number after class.
There you go. It's a toll number, just so you know. It's only 59 cents a minute, don't worry.
No big
Secant and cosecant, what function do they go with when we comment that?
Secant goes with
sine.
cosine.
Cosine.
Just remember the co's do not go together. That's how I remember it.
So for secant, we use cosine. For this first one, second or no second? Second. Why?
It doesn't appear.
Well,
We don't have the angle.
we don't have the angle. Remember, the second key or no second key is depending on whether we have the angle or we're looking for the angle. Here we don't have the angle. We're looking for the angle. So we use the second key. So that means this is going to be a cosine, an inverse cosine. So I put the 3.8 in here. X-1 inside or outside? Inside. When we use the second key, it has to go inside. Yes. This is second. Cosine 3.8. Reciprocal goes inside. 74.74 degrees.
And the x-1 goes on the outside
If you use the second, the x negative 1 goes on the inside.
We have the angle.
If you don't have the angle. Here we didn't have the angle, so we have to use the second key, and x negative 1 goes on the inside. If we have the angle.
How about this one? The x negative 1 goes on the inside if you don't have the angle.
If you don't have the angle, yes.
If the x negative 1 goes on the inside or outside if you have
the angle. Here, let me make a little note here for you. If you have the angle.
Yep. X negative 1 goes
There's two things. One, use
No
just
second.
the key.
Yep, no second.
No second. You got it. And x negative 1 goes outside. If you're looking for the angle, use the second key, and x negative 1 is on the inside.
Sorry.
No problem. So now, let's go back up here. For this one, cosecant of 41 degrees. Second or no second? Second or no second? We have the angle, which means no second. What function are we going to use? Sine. Now, since this button didn't appear on our calculator, that means x negative 1 comes into this at some point. Inside or outside the parentheses?
Equals.
Outside. We had the angle, so it goes outside. So it's sine 41, close, x negative 1, equals 1.5243. Secant is cosine. Cosecant is sine. So down here, cosecant of b. First of all, we see that it does not appear on our calculator, so we know the x negative 1 is going to come into play at some point. What function are we going to use?
Sine negative 1.
This is going to be sine. Do we need to use the second key? Yes, because we're looking for the angle. So second key. 2.34. And since we use the second key, that means the x negative 1 goes
On the inside.
inside. Very good. So second sine 2.34. X negative 1. Close. 25.30 degrees. And finally, secant of 61 degrees. First of all, not on the calculator, so no x negative 1 comes into play. What function do we use? Cosine. Second or no second? We have the angle, so no second. X negative 1 inside or outside? Outside. Since we have the angle, if there's no second, it goes outside. So cosine 61. Close, x negative 1. 2.0627. Now remember what we said about trig functions? Unless you're told otherwise, 4 decimal places. Let's get to something a little more useful. Like I said, those will appear on a quiz. I'm okay with you forgetting about it after that. So have you tried to punch these in quick? Well, let's see how this turned out. All of these, by the way, are buttons that appear on your calculator. So that means we don't have to use what key? X negative 1 will not be used at all. The first one here, sine, second or no second? We have the angle, so no second. So this is really simple. Just sine 27 gives us 454? 4 decimal places, remember. 4540, you're right. Okay, sorry, didn't mean to yell. Next one, cosine. Second or no second here? Second, because we don't have the angle. We know the value of the function. We're looking for the angle. So it's second cosine. But again, pretty simple from there. 3941 gives us what for an angle? 66.80. Who got the first two right so far? Who has no clue where the first two came from so far? Everybody's doing good. Cool. Tangent. Second or no second? Second. So tangent, second tangent, 2.453 gives us what is an angle? 67.82 degrees. Good. Next one, once again, tangent. Second or no second? No second. So just tangent of 81 is 6.3138. Very good. Next one, sine. Second or no second? Second, because we're looking for the angle. So second sine, 0.9111 gives us 65.66 degrees. And then the last one, cosine, second or no second? No second. Just cosine of 63, which is 0.4540. How do you guys feel about all those?
Better about these ones than I do the first ones.
Well, these are the 6 that really do matter. You need to know how to do these 6. The first 6 you will never see in practical applications. Those last 6 are the ones that you're going to see when you encounter problems like this. Pretend that looks like a right angle. Pretending. Let's say that this is 28 millimeters, and this angle here is 37 degrees. I want you to find side B, side C, and angle B. I'll give you a minute. First of all, angle B, how do we find it? Perfect. So 180 minus the 90 minus another 37 is 53 degrees. Okay, side C. Now remember, even though we know this angle, we're going to go back to the one we were given because just in case we made a silly mistake. So from this angle, the side that we know is the 28 millimeters. Which side is that? Opposite. If we're looking for C, C would be the...
Sine.
Careful. Well, which side would it be?
Hypotenuse.
There you go. Yeah, you're just jumping a step ahead of us, though. So we have the opposite. We're looking for the hypotenuse. The trig function that uses those two sides is the sine. So I'm going to write out the definition. Sine of an angle equals opposite over hypotenuse. And now I'm going to fill in my information. Do I know the angle? 37 degrees. Do I know the opposite side? 28. Do I know the hypotenuse? No, that's what I'm looking for. That's C. Now again, the question comes up. Do I know the angle? Yes. If I know the angle, I solve these by making it a proportion. I cross multiply. 1 times 28 is 28. Then I divide by the sine of 37. Giving me 46.53 millimeters. Marking this one on your calendar, Cody. Now for side A or for side B. Once again, we know side A, the 28 millimeters, is the opposite side. Side B would be the adjacent. So that means we are dealing with tangent. Tangent of an angle is opposite over adjacent. Filling in what we know, well, once again, we still know the angle is 37 degrees. We still know the opposite side is 28, but now we're looking for the adjacent side, which is B. And since we know the angle, we're going to make it a proportion. So this will be 1 times 28 divided by the tangent of 37. So 1 times 28 is 28, divided by the tangent of 37. 37.16 we get. Millimeters. How do we double check this? A squared plus B squared equals C squared. Perfect. You've got it. So I'm going to do this. I'm going to type it in like this. I'm going to do the square root of. Side A was the, what was it? 28. So square root of 28 squared plus B is 37.16 squared. This better come out to be really close to 46.53. It may not be exact because of round off, but should be close. 46.528. Yeah, we're right. So we know what makes a right triangle. Yes, sir.
I did all the button pushing equations right.
Yep.
I just got confused on what I was solving for, I guess.
Okay. Well, that's why you've got to keep the formulas written out here. So if I'm solving for C,
And the other two is that.
yeah. Yep. Because you always have to have one side that you know and one side that you're looking for. Or you have to have two sides that you know and an angle that you're looking for, which will be the next example we're going to do. Like this one here. That would be no fun. They don't do that in reality. So we need to find side B, angle A, and angle B. Okay. Now, first of all, here, to find side B, we could just do A squared plus B squared equals C squared. We'll get back to that. Let's find angle A here first. That's the angle we're looking for. What sides do we have? Well, first of all, side C is the hypotenuse. No matter what angle we're looking at, that's the hypotenuse. Now, for the legs, of course, we have to pick an angle, which we've already done, which is angle A. The 290 thousandths is the opposite. Very good. Opposite and hypotenuse is what function? Sine. So our definition, sine of an angle is opposite over hypotenuse. Fill in our information. Do we know the angle? No, that's what we're looking for. It's angle A. Opposite, 0.290, hypotenuse, 0.480. I'll make that look like a 9. So now in this case, we're looking for the angle, which means we have to do second sine. So what we're going to type in is second sine. And the 0.290 divided by 0.480. And of course, we could leave the zeros off if we wanted to. Can't leave the 9 off, though. We kind of need that. Give us 37.17 degrees. How many of you came up with that?
I did.
Only
Perfect.
because I didn't have that one.
Oh, 2.00 instead of 2.90. Yeah, I got it. Gotcha. Now from here, the rest of it, we could go the simple route. We could say that B is just 90 minus that, or 52.83 degrees, since we know the angles have to add up to 180. I don't know if you've noticed, but I always take a shortcut on right triangles. Since I know that this is 90 degrees, instead of using 180 and subtracting, I know that 180 minus 90 leaves 90 degrees to the other two angles. So I just take 90 minus 1 to get the other. For side B then, we can use Pythagorean theorem. Now, we have the hypotenuse in one of the legs, which means we'll be subtracting instead of adding. So it'll be the square root of 0.48 squared minus 0.29 squared. Giving us 0.382. Yeah, 3825 would work. Now, here's a big question. Would that be, and we're talking about rounding. This is very important. If you were asked to round this to the nearest thousandth, which is where I rounded it, you have to be careful. Because let's say you round it to the nearest 10,000th and you come back later and round it to the nearest thousandth, you'll be wrong. Can anybody tell me why? Well, this is 0.38249, right? That's exactly it. It's a compounded rounding error. If you round a number once and you go back to round it again later, you need to make sure you go back to the original number. Because if I round this to the nearest 10,000, or in machining terms to the nearest tenth, 0.3825, because the 9 tells us to round that 4 up to a 5. But if I'm rounding it to the nearest thousandth, it's 0.382 because that's a 4. But if I were to look at this number and round it, I would have rounded that to 0.383. So you've got to be careful not to re-round rounded numbers. Or at the very least to make sure you take them out to enough digits so that you're at least a couple digits past where you would round it. If I had originally rounded this to the 100,000th, it wouldn't matter if I come back and ran it to 1,000. I'm 2 digits away from where I rounded it before. Does that make sense? So you got those compounded rounding errors. Now you could have also used a trig function for this if you wanted to. You could have looked at this and said, hey, pick one of these two sides. And said, hey, let's say you want to pick this one. I know the hypotenuse. I'm looking for, if I use this angle, I'm looking for the adjacent side. The reason I didn't do that, were we given this angle? No. We calculated that angle. Because we calculated that angle, there is a chance that we screwed it up. Whenever possible, and this is just the engineer in me coming out, whenever possible, I go back to information I'm given so that I know I'm using at least accurate numbers. Or at least if those numbers aren't accurate, it's not my fault, it's someone else's fault. If we did everything correctly, we should have been able to use a trig function and it should have come out fine. So let's say we did this. Cosine, let's say we did use the cosine there. Cosine of a number is adjacent over hypotenuse. Our angle was 37.17 degrees. We're looking for the adjacent side, which was B there, I believe. Yes. And we had the hypotenuse of 0.48. Put that over 1. Cross multiply here is just going to be cosine of 37.17 times 0.48. And we get magically 0.382, exactly what we got before. So it should work out either way. But like I said, whenever possible, go back to numbers that you are given. Don't calculate off of numbers that you calculated. Just because the chances of a mistake are magnified. Let's say I have a 10-inch sine bar. Now I realize the one you have in the shop is a 5-inch sine bar. That's okay. If I have a 10-inch sine bar and I want to build a 23-degree, 15-minute angle, what height and gauge blocks do I have to build up here? Okay, so this is called a sine bar, of course, because when you use it, you're generally using what trig function? The sine. So the sine of an angle is the opposite of our hypotenuse. Of course, the hypotenuse is always the length of the sine bar. In this case, it is a 10-inch sine bar. So we have the sine of 23 degrees, 15 minutes, equals x is our opposite side over our 10 inches. Come on. So I'll put this over 1. It's going to be sine of 23 degrees, 15 minutes times 10. And of course, divided by 1. So we got the 23. We got to put in our degrees. 15. Got to put in our minutes. Close and then times 10 and divide by 1. We don't have to worry about. 3.9474. Why did I go down to 1/1000th of an inch there? Because our gauge blocks go down, or to a 10,000th of an inch, I should say. Because our gauge blocks go down to 10,000th of an inch. Let's look at another one. Okay, we're just going to pretend here for a minute. I'm going to put dot, dot, dot. We're going to say that there's 15 holes. I can't accurately draw a picture with 15 holes around a circle, so I'm not going to try. I want you to find if this circle has a diameter of... we better make it a little bigger than that to be realistic. 8 inches. Find center to center distance between holes. You would find that angle there is 360 degrees divided by 15, which will give you 24 degrees. Okay. That's not the angle you really want, though, because there's no right triangle there. But remember, because this is a chord of a circle, if you draw this out perpendicular, cuts the angle in half, cuts the length in half. So you can work with that triangle. This angle would be 12 degrees. So what you have is you have this triangle. This is 12 degrees. You know, the radius of your circle is 4. Where does that go on this triangle? Hypotenuse. Right here. So now this is what we're looking for over here. I'm going to call that y for right now, because x is twice that. To find y, we have, well, this is the hypotenuse. This is which leg? Opposite. Which implies what trig function? Sine. So sine of an angle is opposite over hypotenuse. Do we know the angle? Yes, 12 degrees. Opposite is y, that's what we're looking for. Hypotenuse is 4. Put this over 1, it's just going to be sine of 12 times 4. Point 8316 times 2 will give you x. You got it. 1.6633. Yep. Make more sense now? Good. I'm a math teacher. They removed that before you give us our teaching certificate. So now that I've drawn all that, what is it I'm actually looking for? I want that angle right there. So the biggest part of this problem is finding the missing dimensions. If I complete this triangle here to make a right triangle, This dimension here has to be what?
24.
24. How'd you get it?
Subtract 18 from 42.
Perfect. The 42 minus 18. This one down here has to be
46.
46. Where'd you get that from?
148 minus 39 and the 36.
Perfect. 148, and you subtract the 39 and the 63. You have 46. So now finding that angle, the two sides, these are both legs. The 24 is which leg? Opposite, and 46 is adjacent, which means we're dealing with a tangent. So tangent of an angle equals opposite over adjacent. Filling in here, do we know the angle? No. That's what we're looking for. Opposite side's 24, adjacent is 46. Now, just a way to double check ourselves here. Since the opposite side is smaller than the adjacent side, we know that this angle is less than 45 degrees. So anyway, we're looking for the angle, which means we are doing inverse tangent. So second tangent of 24 divided by 46 gives us what?
27 degrees, 33 minutes.
So 27 degrees, 33 minutes, or is a decimal 27.55? You get the extra gold star for the day.
Did you say that if the opposite is smaller than the adjacent, the
Angle's less than 45. Yeah, 45 degree angle, the opposite and the adjacent are the same length. And these are just, we talked about this last semester about things things you should be estimating in your head before you punch stuff in your calculator, just in case you screw up. That's one of them. You know that, okay, that opposite side is smaller, so you know it's less than 45. If your calculator spits out something bigger than 45, something's way wrong.
and that's like, what is it, diversity constant involved in that, isn't there?
Yeah, there are.
There's 0.7071.
Well, that's the sine of a 45 degree angle. It's 0.707070. Yeah.
And then, what's the 1.414?
That would be that's the square root of 2. That would be if you have a 1 to 1 and it's a 45 degree angle, the hypotenuse is 1.414.
Certain things stick and other things just can't.
So, tell me, how high does that ball stick up above the V block? We've only got 2 minutes left, so I don't have time to let you guys try it on your own. So I guess I'm going to have to do it quick. So we're going to look at, this is going to be a right triangle. We know this is 12, and this is 40. So I'm going to redraw the triangle down here. I'm going to draw it like this. 40 and 12, right angle. What I want is the hypotenuse here. So that's going to be the sine. I know the angle, so I'm going to put in the 40 degrees. My opposite side is 12. Hypotenuse is what I'm looking for. Put this over 1, so it's 1 times 12 divided by the sine of 40. Giving me 18.67. So now coming up here, this is 18.67. This is 12. So that is 40.67 total. The difference, if I subtract 30, it's 10.67 millimeters. Okay, I've got good news, better news, and best news. The good news is there's a quiz next door at 8:30. The better news is there's a quiz for this class right now as well. The best news is we're out of time, so you get to take it home and bring it back tomorrow.
All right.